They called it the Era Comet, though most people who saw it couldn't believe it could fly at all. No propeller spinning at the front, just two strange bulges under the wings that seemed to breathe fire. When test pilot Robert Stanley climbed into the cockpit on October 1st, 1942, he was about to make history, though nobody outside a tiny circle of military officials would know about it for years. The Germans, so proud of their advanced aviation technology, would later be stunned to learn that while they were still perfecting their jet fighters, the Americans had already been flying one in secret over the California desert. This is the remarkable story of the P-59 Era Comet, a plane that never fired a shot in anger but changed everything about how we think about air combat. The story really begins not in America, but across the Atlantic Ocean, in the workshop of a brilliant British engineer named Frank Whittle. While the world was still marveling at propeller-driven fighters that could barely break 400 miles per hour, Whittle was dreaming of something revolutionary, an engine that could push air out the back so fast it would thrust an airplane forward without any propellers at all. By 1941, his dream had become reality in the form of the Gloucester E.2839, Britain's first jet aircraft. General Henry Hap Arnold, commanding general of the United States Army Air Forces, witnessed a demonstration of this British jet in April 1941. What he saw that day shook him to his core. Here was technology that could revolutionize aerial warfare, and America didn't have anything like it. The Germans were already working on their own. Jets' intelligence reports suggested they were making rapid progress. If America didn't act fast, it risked being left behind in what could be the most important technological race of the war. Arnold moved with remarkable speed. He didn't just ask for information about the British jet engine, he asked for the engine itself. In an unprecedented act of technological cooperation, the British agreed. On October 1st, 1941, exactly 1 year before the P-59 would make its first flight, two examples of Whittle's revolutionary turbojet engine were loaded into the bomb bay of a consolidated B-24 Liberator and flown across the Atlantic to Massachusetts. Along with the engines came a small team of Power Jets engineers, and most importantly, the blueprints for an even more powerful engine that was still in development. General Electric got the contract to produce an American version of the engine. The choice made sense. GE had experience with turbines and superchargers, and they had the facilities to handle such a secret project. A sign reading simply "miscellaneous" was posted outside their Lynn, Massachusetts facility to discourage curiosity. Inside, engineers worked around the clock to understand and replicate Whittle's genius. They called the engine a spare part in all documentation, just another layer of deception in what was becoming one of the most secretive projects of the war. But an engine without an airplane is just an expensive piece of machinery. Arnold needed someone to build a fighter around these new power plants, and he turned to Lawrence Bell, president of Bell Aircraft Corporation. The meeting that would change American aviation forever took place on September 5th, 1941. In Washington, D.C., Arnold didn't mince words. He needed a jet fighter, he needed it fast, and it had to be absolutely secret. Bell accepted the challenge immediately. His company had a reputation for innovative designs. They weren't overloaded with production contracts like other manufacturers, and critically, they were located near General Electric's facilities. Within days, Bell's best engineers were pulled from their regular work and moved to a former Pierce-Arrow automobile factory in downtown Buffalo. The secrecy was extraordinary. The engineers worked on the second floor of a three-story building where a Ford car dealership had once operated. Every window was welded shut and painted over. Armed guards patrolled the building 24 hours a day. The deception went even deeper. To throw off any potential spies, the Army Air Forces gave the project the designation XB-59A. This was brilliant misdirection. There had already been a Bell XB-59 project, a conventional twin-boom pusher propeller fighter that had been cancelled. By reusing the number with an A suffix, they made it seem like this was just a minor modification of an existing design, not the revolutionary leap it actually was. As 1942 began, the pressure was intense. Intelligence reports from Europe painted an alarming picture. The Germans had flown their Heinkel 178, the world's first jet aircraft, back in August 1939. They were now working on the Messerschmitt Me 262, which promised speeds over 500 miles per hour. The British were making progress with their Gloucester Meteor. America was playing catch-up in a race where second place might mean losing the war. The design that emerged from Bell's secret workshop was conservative by necessity. The XB-59A looked conventional enough, a straight-winged, all-metal fighter with tricycle landing gear, a trademark of Bell designs. But instead of a propeller at the front, it had two jet engines slung under the wing roots in streamlined nacelles. The cockpit was pressurized, heated by air bled from the engines. The planned armament was impressive. Two 37 cannons that could punch through any armor the Germans or Japanese could put in the air. Building the first XB-59A presented unique challenges. The components were so large they couldn't fit in any elevator in the building. When the time came to move the completed aircraft, workers had to knock a hole in the brick wall of the second floor and lower three large crates onto railroad flat cars waiting below. Even the journey to the test site was shrouded in secrecy. An air compressor was hooked up to the crates to keep the engine turbines spinning during transport. The engineers were terrified that vibrations from the train might damage the delicate bearings. The destination was Muroc Army Airfield, now known as Edwards Air Force Base, in the Mojave Desert of California. This remote location, with its vast dry lake beds and sparse population, was perfect for testing secret aircraft. The crates arrived on September 19, 1942, and Bell's team immediately set to work assembling their creation. To maintain the deception, whenever the aircraft was visible on the ground, they attached a dummy wooden propeller to the nose. Any distant observer would see what looked like just another conventional fighter. Robert Stanley, Bell's chief test pilot, had been preparing for this moment for months. He had studied every aspect of jet propulsion, understanding that this new form of flight might behave differently from anything he had experienced. On October 1st, 1942, Stanley was conducting what was supposed to be just a high-speed taxi test. The jet engines, designated IA by General Electric, each producing 1,250 pounds of thrust, roared to life with a sound unlike anything heard before on an American airfield. As Stanley accelerated down the lake bed, the aircraft responded eagerly. Too eagerly. Before he quite intended it, the XB-59A lifted off the ground. America had entered the jet age, albeit accidentally. Stanley kept the aircraft airborne briefly before setting it back down, his heart racing not from fear but from exhilaration. This thing actually worked. The next day, October 2nd, Stanley made the first official flight, keeping the aircraft aloft for 30 minutes and reaching speeds that, while not spectacular by later jet standards, were still impressive for a first flight. After landing, Stanley did something that showed both confidence in the design and respect for the military officers who had made it possible. He offered the aircraft to Colonel Lawrence Craigie, who had come from Wright Field in Dayton to witness the tests. Craigie climbed into the cockpit and, with Stanley's quick instruction, became the first U.S. military pilot to fly a jet aircraft. The flight test program that followed revealed both the promise and problems of jet propulsion. The P-59 was smooth in flight, with none of the vibration that plagued propeller-driven aircraft. The acceleration was steady and powerful, but there were serious issues. The engines were temperamental and unreliable. They consumed fuel at an alarming rate. The heat generated by the jets was beyond anything the existing metals had been designed to handle. Turbine blades would frequently break, sometimes destroying the entire engine. Most troubling was the aircraft's performance. While the Germans were promising jets that could exceed 500 miles per hour, the XB-59A struggled to break 390. The problem was partly the engines. They simply didn't produce enough thrust, but also the design itself. The underslung engine placement created enormous drag. At speeds over 290 miles per hour, the aircraft would begin to snake, yawing back and forth unpredictably. This made it nearly impossible to aim weapons accurately. By early 1943, 13 pre-production YP-59A aircraft had been ordered. These incorporated numerous improvements based on the test flights. The canopy was changed from a hinged design to a sliding one. The engines were upgraded to the I-16 model, later designated the J-31 GE3, producing 1,650 pounds of thrust. But even with these improvements, the performance gains were marginal. Top speed increased by just 5 miles per hour. The security around the project remained intense. In March 1943, when heavy rains flooded Rogers Dry Lake at Muroc, the second prototype had to be moved to an auxiliary airfield. Rather than fly it and risk exposure, the aircraft was towed 35 miles over public roads to Hawes Field. The dummy propeller was attached, and the entire aircraft was covered with tarps. To any curious observer, it looked like just another damaged conventional fighter being transporting for repair. The Army Air Forces conducted a crucial series of tests in February 1944 that would determine the P-59's fate. The jet was pitted against two of America's best propeller-driven fighters, the Lockheed P-38J Lightning and the Republic P-47D Thunderbolt. The results were devastating for the jet's supporters. Not only did the P-59 fail to outperform these conventional fighters, it was actually inferior in many respects. The P-38 and P-47 were faster in level flight, climbed better, and were far more maneuverable. In mock dogfights, the prop fighters consistently gained the advantage. One YP-59A was sent to Britain in exchange for a Gloucester Meteor, becoming the first American jet to fly in European skies. The British pilots who tested it at Farnborough were polite but unimpressed. Compared to their Meteor, which could reach speeds of 460 miles per hour, the American jet seemed sluggish and underpowered. One RAF test pilot reportedly commented that it flew like a brick with wings. The aircraft made only 11 flights in Britain before being quietly returned to the United States. Despite these disappointments, the Army Air Forces proceeded with production. On March 11, 1944, a contract was confirmed for 100 P-59A Aerocommets. The name had been chosen by Bell employees who felt their creation needed something more inspiring than a letter number designation. But reality soon intruded. By October, after extensive evaluation, the order was cut to just 50 aircraft. The official report was damning. It is not believed that the P-59 airplane is operationally or tactically suited for combat, nor is it believed that any modifications to this aircraft, short of a completely new design, would improve its combat suitability. The report did offer one ray of hope. The P-59 will make an excellent training ship in that its low wing loading makes the airplane very safe for transition flying, and the fact that it has two engines is an added safety factor. This would become the P-59's primary role, not as a combat aircraft, but as a trainer to prepare American pilots for the next generation of jets that were already in development. The production P-59 as began arriving at operational units in the fall of 1944. 20 were built with the A designation, followed by 30 P-59Bs that featured additional fuel tanks in the wings. The 412th Fighter Group at Muroc became the primary operator, tasked with developing tactics and procedures for jet operations. For many American pilots, their first experience with jet propulsion came in the cockpit of a P-59. These pilots discovered a completely different world of flight. There was no torque from a spinning propeller to counteract. The acceleration was smooth and continuous rather than the aggressive pull of a prop. The sound was different too. Instead of the angry snarl of a radial engine or the smooth purr of an inline, there was a steady whistle that rose to a scream at full throttle. Landing approaches had to be completely relearned. Without a propeller providing instant response to throttle changes, pilots had to plan much further ahead. The training value of the P-59 extended beyond just pilot familiarization. Ground crews learned how to service jet engines, which required completely different procedures from piston engines. There were no spark plugs to change. no propellers to balance. But there were new challenges, like managing the extreme heat of the exhaust and understanding the unfamiliar whine that might indicate a failing turbine blade. Some P-59s were modified for special purposes that pushed the boundaries of aviation technology. Two YP-59 as were converted into drone aircraft, controlled remotely by operators in other P-59s flying nearby. This was revolutionary for its time. The idea that a fighter aircraft could be flown without a pilot aboard was pure science fiction to most people. The drone program had mixed success. One drone crashed during takeoff in March 1945, but the program continued with a P-59B taking its place. The surviving drone, painted bright orange and christened Reluctant Robot, made history when Colonel Craigie became the first Air Force officer to fly in a remotely controlled aircraft. An amusing incident occurred during tests near Akron, Ohio. The drone's flaps would occasionally deploy without any command from the control aircraft. After weeks of troubleshooting, engineers discovered that the radio frequency used to control the flaps was identical to the one used by the Akron Police Department. Every time a police officer made a radio call on that frequency, the P-59's flaps would drop. Meanwhile, even as the P-59 was entering service as a trainer, its replacement was already flying. The Lockheed P-80 Shooting Star had made its first flight on January 8, 1944, just 143 days after the contract was signed. The P-80 addressed all of the P-59's shortcomings. It was faster, more maneuverable, and more reliable. It would become America's first operational jet fighter, seeing limited service in Italy before the end of World War II and extensive combat in Korea. The psychological impact of the P-59 on German intelligence and military thinking was more significant than its modest performance might suggest. Throughout the war, the Germans had maintained a sense of technological superiority, especially in advanced aircraft design. They knew about British jet development. German pilots had encountered Gloster meteors in combat by 1944. But the Americans were seen as technically competent but uninspired, focused on mass production rather than innovation. When German intelligence first received reports of an American jet fighter, many dismissed them as propaganda or misidentification. How could the Americans, who had entered the war with obsolete aircraft like the P-40 and P-39, suddenly have jets? Even when photographic evidence emerged, some German analysts believed it must be a British aircraft with American markings. The reality was even more frustrating for German intelligence. The P-59 program had been so secret that even after the war, when captured German documents were examined, it became clear they had never developed a clear picture of American jet development. They knew something was happening. Reports from agents in the United States mentioned unusual activity at certain factories and strange aircraft seen over the California desert, but the details remained elusive. One German intelligence report from late 1944, discovered after the war, speculated that the Americans might have one or two experimental jet aircraft, but concluded that mass production is unlikely before 1946. In reality, by that time, 50 P-59s had already been built and the P-80 was entering production. The Germans had drastically underestimated American industrial capability and engineering adaptability. This intelligence failure had strategic implications. The German High Command, believing they had a monopoly on operational jet fighters with their Me-262, made tactical decisions based on this assumption. They dispersed their jet production facilities and training bases, believing they had time to perfect their jets before the Allies could respond. Had they known that America was already training dozens of pilots on jets and that the P-80 was coming, they might have accelerated their own programs or changed their tactical approach. For the American pilots who flew the P-59, the experience was transformative, even if the aircraft itself was disappointing. Captain Chuck Yeager, who would later become the first person to break the sound barrier, flew the P-59 at Muroc in 1944. He later recalled that while the aircraft was a dog, In terms of performance, it opened his eyes to the possibilities of jet propulsion. The smooth, vibration-free flight and the potential for much higher speeds convinced him that jets were the future. The P-59 also played an unexpected role in the early Cold War. When the Korean War erupted in 1950, America's jet fighter force was built on the foundation laid by the P-59 program. The pilots flying F-80 Shooting Stars and F-86 Sabres over Korea had, in many cases, gotten their first taste of jet flight in a P-59. The maintenance procedures, tactical doctrines, and operational concepts developed during the P-59's service informed how America employed its jets in combat. One of the most interesting what-ifs of aviation history concerns the P-59's potential use in combat. In early 1945, as the war in Europe was winding down but the invasion of Japan loomed, there were serious discussions about deploying P-59s to the Pacific. The plan was to use them as night fighters, taking advantage of their smooth flight characteristics and the psychological impact their unusual appearance and sound might have on Japanese pilots. The idea made some sense. Japanese pilots, trained to engage propeller-driven aircraft, would have been completely unprepared for jets. The P-59's poor performance against American fighters might not have mattered against Japanese aircraft that were generally slower and less heavily armed than their German counterparts. But the atomic bombs ended the war before this plan could be implemented. The P-59's influence extended beyond military aviation. Several aircraft were used in civilian research programs after the war. NASA's predecessor, the National Advisory Committee for Aeronautics, used P-59s to study jet engine behavior at high altitude. These tests contributed to the understanding of jet engine performance that would eventually lead to civilian jet airliners. One particularly innovative use of the P-59 was in the development of aerial refueling techniques. In 1948 and 1949, experiments were conducted where a P-59A was towed behind a B-29 bomber to extend its range. The idea was that jet fighters, with their notorious fuel consumption, could be carried along with bomber formations and released when enemy fighters appeared. The experiments were ultimately unsuccessful. The stress on the pilots and the effect on the B-29's performance made it impractical, but they contributed to the development of the aerial refueling systems that are now standard in military aviation. The human stories behind the P-59 program are as compelling as the technical details. Consider the workers at Bell's secret facility in Buffalo. Many were women, part of the Rossi, the riveter, workforce that powered American war production. They worked long hours in a windowless building, unable to tell their families what they were doing, knowing only that it was vital to the war effort. Some didn't learn they had built America's first jet fighter until decades after the war. There was Jack Woolams, Bell's assistant test pilot, who became famous for his practical jokes during the P-59 test program. Woolams would sometimes wear a gorilla mask while flying the P-59, deliberately approaching other aircraft whose pilots had no idea jets existed. Imagine being a pilot in 1943, seeing what appears to be a gorilla flying an aircraft with no visible propeller. More than one pilot returned to base refusing to file an official report about what they'd seen, fearing they'd be grounded for hallucinations. The international dimension of the P-59 story is often overlooked. The aircraft represented not just American achievement, but Allied cooperation. The British, despite being at war and desperately needing every technological advantage, shared their most advanced engine technology with the Americans. Frank Whittle himself spent time in the United States, helping General Electric understand the principles of jet propulsion. This cooperation laid the groundwork for the special relationship in aerospace that continues today. The Soviet Union was also watching American jet development closely, though from afar. Soviet intelligence knew about the P-59 program earlier than the Germans, partly because of their more effective spy network in the United States. Stalin himself reportedly demanded to know why the Soviet Union didn't have jets when the Americans did. This spurred the development of Soviet jets, leading to aircraft like the MiG-15 that would challenge American air superiority in Korea. The P-59's safety record was remarkably good for such a revolutionary aircraft, though there were casualties. Several pilots died during the test program, including one who was killed when his YP-59A broke apart in a dive test. The entire tail section separated from the aircraft, a catastrophic structural failure that led to significant design changes. Another pilot died when he attempted a belly landing after engine failure and the aircraft caught fire. These tragedies contributed valuable lessons about jet aircraft design and emergency procedures. The end of the P-59's operational career came quickly. By 1946, most had been withdrawn from service. Some were sold to civilian operators for research purposes. Others were used as ground targets for weapons testing. A few were preserved in museums, though only 6 survive today. Most were simply scrapped, their aluminum recycled into consumer goods for the booming post-war economy. But the P-59's legacy lived on in unexpected ways. The aircraft inspired a generation of aerospace engineers who would go on to design the jets of the 1950s and 1960s. Some of the young engineers who worked on the P-59 program would later contribute to projects like the Boeing 707, bringing jet travel to millions of civilians. Others would work on military projects like the B-52 bomber and the F-104 fighter. The economic impact of the P-59 program was significant. The total cost of the program, including development and production, was approximately $10 million, roughly $150 million in today's money. This might seem modest compared to modern military aircraft programs, but it represented a massive investment in unproven technology during wartime. The program employed thousands of people and created an entire industry around jet engine production and maintenance. The P-59 also influenced American military doctrine in ways that weren't immediately apparent. The experience of trying to integrate a revolutionary new technology into existing force structures taught valuable lessons about change management in military organizations. These lessons would be applied again and again as new technologies like helicopters, missiles, and eventually stealth aircraft were introduced. One of the most poignant aspects of the P-59 story is how quickly it was forgotten by the public. Unlike the P-51 Mustang or the B-17 Flying Fortress, which became icons of American air power, the P-59 faded from memory almost as soon as it left service. Part of this was intentional. The aircraft had been classified for so long that by the time its story could be told, the public had moved on to fast. But for those who knew its story, the P-59 represented something special. It was proof that America could compete in the most advanced fields of technology. It showed that American industry could adapt quickly to new challenges. Most importantly, it demonstrated that even a failed aircraft could contribute significantly to ultimate victory. The international reaction to the revelation of American jet capability varied by country. The British, who had shared their technology, were pleased but not surprised. They had expected the Americans to develop jets quickly once given the basic technology. The French, rebuilding their aviation industry after the war, saw it as evidence that they needed to develop their own jets quickly or risk being left behind. In Japan, the revelation that America had been flying jets since 1942 was particularly shocking. The Japanese had been working on their own jet, the Nakajima Kicker, which made its first flight just days before the war ended. To learn that the Americans had been 3 years ahead was a blow to national pride and contributed to the recognition that Japan had been technologically outmatched. The P-59's influence on popular culture was minimal compared to other World War II aircraft, but it did appear in some unexpected places. In the 1950s, when science fiction was booming, the P-59 often appeared in movies and TV shows as a futuristic fighter, despite being already obsolete. Its unusual appearance The lack of a propeller made it look alien to audiences accustomed to conventional aircraft, made it perfect for depicting advanced technology. The technical lessons learned from the P-59 program were invaluable. Engineers discovered that jet engines required completely different materials than piston engines. The extreme heat generated by the jets led to advances in metallurgy that would benefit not just aviation, but many other industries. The need for better fuel management systems led to innovations in pumps and controls that would later be used in everything from rockets to industrial equipment. The P-59 also contributed to advances in aerodynamics. The problems with stability at high speed led to research into swept wings and area ruling that would define jet aircraft design for decades. While the P-59 itself had straight wings, the data gathered from its flight tests informed the design of swept-wing aircraft like the F-86 Sabre. One often overlooked aspect of the P-59 story is its contribution to flight safety. Because it was used primarily as a trainer, extensive effort was put into making it as safe as possible. The procedures developed for engine failure in jets, for example, were first worked out on the P-59. The emergency protocols for flameouts, compressor stalls, and other jet-specific problems were all developed during the P-59's service life. The environmental impact of the P-59 program was significant for its time, though tiny by modern standards. The jet engines consumed fuel at rates that seemed astronomical to people accustomed to piston engines. A P-59 could burn through its entire fuel load in less than an hour of flight. This led to early recognition that jet aviation would require massive infrastructure investments in fuel production and distribution. The P-59 program also highlighted the importance of test facilities. Muroc Army Airfield was transformed from a remote emergency landing field into what would become Edwards Air Force Base, the premier flight test center in the world. The requirements of testing, jets' long runways, restricted airspace, specialized equipment, drove the development of test facilities that are still in use today. The political implications of the P-59 program extended beyond military considerations. The success of the program, even if the aircraft itself was disappointing, demonstrated that American industry could rapidly adapt to new technologies. This became a key argument for increased government investment in research and development during the early Cold War. The model of government-industry cooperation pioneered in the P-59 program would be replicated in everything from the space program to the development of the Internet. Personal accounts from P-59 pilots provide vivid insights into what it was like to fly America's first jet. Many described the eerie quiet when the engines were throttled back. Without the constant vibration and noise of a piston engine, they could hear the wind rushing past the canopy. Others talked about the smooth acceleration, like being pushed by a giant hand rather than pulled by a propeller. But they also described the frustrations. The engines were temperamental, often refusing to start in cold weather. The acceleration was smooth, but slow. It took forever to reach operational altitude. The fuel consumption meant that flights were often cut short, with pilots constantly watching their gauges and calculating whether they had enough fuel to make it home. The maintenance crews had their own challenges. Jet engines required different tools, different procedures, and different safety equipment. The extreme heat of the exhaust could melt conventional materials. Ground crews had to be retrained to avoid walking behind the aircraft when the engines were running. The jet blast could literally blow a man off his feet. The strategic deception around the P-59 program was masterful. The use of the dummy propeller was just one element. False information was deliberately leaked, suggesting that Bell was working on an improved version of the P-39 Airacobra. Shipping documents were falsified. Even the test pilot's logs were censored, with any mention of jets replaced with conventional terminology. This secrecy had unexpected consequences. Because so few people knew about the program, resources were sometimes hard to obtain. Parts that were urgently needed would be delayed because supply officers didn't understand their priority. Security was so tight that even people with legitimate need to know were sometimes denied access. The German reaction to the revelation of American jet capability was complex. On one hand, there was genuine surprise that the Americans had managed to develop jets so quickly. On the other, there was a certain satisfaction that the P-59's performance was so poor compared to German jets. Captured German documents show that some Luftwaffe officers actually felt vindicated. They had always said American aircraft were inferior, and here was proof that even American jets couldn't match German engineering. But wiser German officers recognized the real threat. It wasn't the P-59 itself, but what it represented: American industrial capacity applied to jet technology. They understood that while the first American jet might be inferior, the second and third generations would likely be formidable. Hermann Goering, head of the Luftwaffe, reportedly said that when he learned about American jets, he knew Germany could not win a prolonged war. The P-59's role in the development of jet combat tactics is often underestimated. Because it was never used in combat, pilots had to imagine how jet versus jet combat might work. They developed theories about energy management, altitude advantage, and speed conservation that would prove crucial in Korea when American jets faced Soviet MiGs. The tactical doctrine developed in P-59 squadrons formed the basis for jet fighter tactics that are still taught today. The 412th Fighter Group, the primary operator of the P-59, became a breeding ground for future jet aces. Many of the pilots who would distinguish themselves in Korea got their first jet experience in P-59s. They learned that jets required a different mindset, thinking further ahead, managing energy more carefully, and understanding that speed was life in jet combat. The P-59 also played a role in the development of jet trainers. The recognition that jets required specialized training aircraft led directly to the development of the T-33, which would train thousands of pilots worldwide. The lessons learned from using the P-59 as a trainer, what worked, what didn't, what pilots needed to know, informed the design of purpose-built jet trainers. The international proliferation of jet technology was accelerated by the P-59 program. Once it became known that America had jets, every nation with aviation ambitions wanted them. The French developed the Dassault Aragon, the Swedes the Saab 29-tonner, and even smaller nations began planning for jets. The P-59 had proven that jet technology wasn't the exclusive province of major powers. The cost-benefit analysis of the P-59 program is interesting. While the aircraft itself was a disappointment, the program as a whole was incredibly valuable. For roughly $10 million, America gained entry into the jet age, trained hundreds of pilots and thousands of ground crew, developed infrastructure and procedures for jet operations, and laid the groundwork for the jets that would dominate Korean skies just 8 years later. The P-59's contribution to aerospace medicine shouldn't be overlooked. Jets introduced new physiological challenges: higher altitudes, faster acceleration, and different vibration patterns. Flight surgeons studying P-59 pilots developed new understanding of how the human body responds to jet flight. This research contributed to the development of better oxygen systems, G-suits, and ejection seats. The industrial impact of the P-59 program extended far beyond aviation. Companies that supplied components had to develop new materials and manufacturing techniques. These innovations found applications in other industries. The high-temperature alloys developed for jet engines were used in chemical processing. The precision manufacturing techniques were applied to everything from automobiles to appliances. The P-59 program also influenced education. Universities began offering courses in jet propulsion. Technical schools developed programs to train jet engine mechanics. The need for engineers who understood jets led to expansion of aerospace engineering programs. Many of the engineers who would lead America's space program got their start working on problems identified during the P-59 program. The cultural impact of the P-59 was subtle but real. It represented a break with the past. The romantic era of silk scarves and open cockpits was definitely over. Jets were the future, and that future was about technology, speed, and precision. The P-59 helped Americans understand that the post-war world would be fundamentally different from what had come before. In the intelligence community, the success of keeping the P-59 secret for so long became a model for future programs. The techniques developed compartmentalization, cover stories, physical security, would be refined and used for everything from the U-2 spy plane to the Manhattan Project's continuation in the Cold War. The P-59 program proved that America could keep secrets when necessary. The P-59's influence on aircraft design philosophy was significant. It demonstrated that revolutionary technology didn't always produce revolutionary results. Sometimes, incremental improvement of proven technology could outperform radical innovation. This lesson influenced American aircraft development for decades, leading to a preference for evolutionary rather than revolutionary designs. The diplomatic aspects of the P-59 program had long-lasting effects. The willingness of the British to share their jet technology with America strengthened the special relationship between the two nations. This cooperation would continue through the Cold War, with both nations sharing aerospace technology and intelligence. The P-59 program established patterns of cooperation that persist today. The P-59 also influenced procurement practices. The problems with the aircraft led to better testing and evaluation procedures. The military learned that new technology needed extensive testing before committing to large-scale production. This lesson, learned at relatively low cost with the P-59, would save billions of dollars in future programs. As we look at the broader picture, the P-59 represents a crucial moment in American history. It was the point at which America fully embraced its role as a technological superpower. The success of the program, despite the aircraft's limitations, gave American leaders confidence that they could compete with anyone in advanced technology. This confidence would drive American policy throughout the Cold War. The human cost of the P-59 program, while small compared to combat operations, shouldn't be forgotten. Test pilots died pushing the aircraft to its limits. Ground crew were injured in accidents. Workers in factories were exposed to dangerous chemicals. These sacrifices, made in the pursuit of technological advancement, were part of the price of progress. The P-59 story also illustrates the importance of failure in innovation. Had the P-59 been a complete success, America might have committed to a design that would have been obsolete within years. Its limitations forced engineers to think harder, to innovate more, to push boundaries further. The P-80 Shooting Star, which replaced it, was better because of lessons learned from the P-59's failures. Looking at recently declassified documents, we can see that the P-59 program was even more influential than previously thought. Soviet intelligence reports show that they closely monitored the program and adjusted their own jet development in response. Chinese documents from the 1950s reference the P-59 when discussing their need to develop indigenous jet capability. The aircraft's influence rippled across the globe in ways its designers never imagined. The preservation of surviving P-59s has become a priority for aviation historians. Of the 6 remaining aircraft, each tells a different part of the story. The one at the Smithsonian represents the triumph of American innovation. The one still being restored at the Planes of Fame Museum represents the ongoing effort to preserve this history. Each surviving aircraft is a tangible link to a pivotal moment in aviation history. The P-59 story challenges our understanding of success and failure. By conventional measures, it was a failure. It never saw combat, was inferior to contemporary propeller aircraft, and was quickly replaced. But by broader measures, it was a crucial success. It gave America entry into the jet age, trained the people who would win air superiority in Korea, and demonstrated that American industry could master any technology. As we reflect on the P-59's legacy, we see patterns that resonate today. the challenge of integrating revolutionary technology into existing systems, the importance of international cooperation in advancing technology, the need for secrecy balanced against the benefits of openness. These issues, first confronted in the P-59 program, remain relevant in our modern world of rapid technological change. The story of the P-59 also reminds us that history is often written by the victors, but not always about the victors' successes. The P-59 was, by most measures, not a success, yet its story has been preserved, studied, and celebrated. This speaks to a certain American willingness to acknowledge and learn from failures, to see value even in what doesn't work perfectly. In the end, the Bell P-59 Era Comet stands as a testament to American adaptability and determination. Faced with the challenge of jet technology, America responded not with one perfect solution, but with rapid experimentation, learning, and adaptation. The P-59 was the first step in a journey that would lead to American aerospace dominance. The emotional heart of this story lies not in the aircraft itself, but in what it represented to those who built, flew, and maintained it. For them, the P-59 was more than just aluminum and steel. It was proof that America could innovate, could adapt, could compete with anyone. It was a symbol of American industrial might and technological prowess. Even in its imperfection, it was perfect for its purpose, to teach America how to build and fly jets. And perhaps that's the most powerful twist in this entire story. The Germans, who prided themselves on their technological superiority, who had pioneered jet flight, who built the faster Me-262, ultimately lost the war and the technological race. The Americans, starting from behind, building what many considered an inferior jet, learned from every mistake, adapted with each failure, and emerged from the war positioned to dominate aerospace for generations. The P-59 never shot down an enemy aircraft. It never bombed a target. It never even flew in combat. But in its quiet way, flying over the California desert with a dummy propeller to fool prying eyes, it changed everything. It proved that in the race for technological supremacy, it's not always about being first or being best. Sometimes it's about being willing to try, to fail, to learn, and to keep pushing forward. When those German intelligence officers finally learned about the P-59, when they saw the photographs and read the specifications, many of them laughed. Such an inferior aircraft, they thought. Such typical American engineering, crude, underpowered, inelegant. But they missed the point entirely. The P-59 wasn't about building the best jet. It was about learning how to build jets at all. And once America learned that lesson, once those pilots and engineers and ground crews understood jet technology, there was no stopping them. Today, when you see an American fighter jet streak across the sky, whether it's an F-22 Raptor or an F-35 Lightning II, you're seeing the legacy of the P-59 Era Comet. Every jet that America has built, every pilot who has flown one, every mission they've accomplished, all of it traces back to those secret days in 1942 when a strange aircraft without a propeller lifted off from a California lakebed. The Germans were shocked when they learned about America's first jet fighter. But the real shock came later, when they realized what that modest, underperforming aircraft truly represented. Not the end of American aerospace development, but the beginning. The P-59 Era Comet might have been a disappointing aircraft, but it was the first note in a symphony of American jet aviation that continues to this day. And in that sense, it was perhaps the most successful failure in aviation history.